This next operation is just a regular tap, but I really like Fusion 360 where you can program tap with chip break. It's a little deep, so let's see how it does with the deepness. Uh-oh, whoops. So what I did wrong was Hey guys, welcome back. I thought I'd bring you in on another project that I've been working on. I have a few of these tool holders for my Logan Lathe, and this size is the ½ inch to, I think it accepts a ½ inch to a 5/8 inch tool. It's not the smallest. I think the smallest is an AX. This size is the BX. The BXA, I think it is. It's also stamped with 250202 on the side. Like I said, I've got 4 of these, but I've got a lot more tools that I'd like to set up in the lathe and then not worry about, you know, adjusting for centerline. So this, and actually let me bring you over to the lathe and I'll explain where I'm going with this. When I bought this lathe, this tool post holder was on here, and no matter how far I backed these nuts up, this adjustment nuts up, I couldn't bring my center line, I couldn't adjust it to center line. It was always too high. I couldn't bring it down low enough. And so with all of my tool holders, I skimmed using the sile. I took some material off the bottom of these so that these can rest lower here, and I think it's because when this Logan was made with this cross slide and whatnot, when this Logan was made, it wasn't designed, it was too high to be used with this, and or one would need to use custom custom high-speed steel tooling like I have here. This is a tool that I made. It's a double-side chamfer. But if you want to use, you know, the newer carbide stuff, for me it was too high. So this left me with 2 options. You know, I could buy new holders and then modify them like this, which would have been the easiest way to do it, or I could design my own holders. I use Fusion 360. I designed my own holders, the height, you know, all the specs that I want to fit this, and then use the Sile X7 to make this tool. It's not that complicated. Why not? I've got the mill, I've got the time, so I went ahead and did that. I ran a couple parts yesterday. I think all the operations take me about an hour to mill this, because I got to flip it 5 times. There are 5 setups just to make sure that I get it how I want it. But yeah, but it was a fun experience. Since I went ahead and engraved the front with the same serial number, 250202, and then since this is my creation based off of what's out there, I branded it that my shop made it, put my touch mark on here, and then put that it was made in the USA. Now if I wanted to buy these from McMaster Car, this would cost me, I think, $75 plus tax and shipping, so that's about $100 actually. Tax, shipping, they usually charge $75, $85, $90, about $90 it would probably cost me to buy from McMaster Car. Doing it myself, I probably did it for half of that. So pretty cool job. So I ran this part last night for Easter and I filmed it. Pretty boring footage, but if you'd like to see the Sile in action, if you'd like to see specifically the Sile handle a dovetail cutter, that was fun. It's a 60-degree dovetail cutter. Please continue watching this movie. If you don't want to see boring feeds and speeds and me making chips, I'll catch you on the next one. Alright, welcome to Fusion 360. I'm trying something new today, guys. This is actually the web browser of Fusion 360. I haven't found a recording software yet that allows me to, pick up all of these extra windows when I, for example, if I wanted to look up this toolpath. A lot of the times it doesn't. This is recognized as a new window. Their screen recording software that I've tried has been hit or miss. But here you go. So this is the setup. I'll briefly go over this, and then we'll get right into making the chips. As it progresses in the toolpaths and we kind of sample some of these different operations, I'll put, the tool that I'm using. Remind us, tool I'm using, feeds and speeds. So again, got this set up into 5 setups. This first setup is, the 5 setups are just the dovetail side of it. Okay. Then I'm going to flip that part, take the hat off, and do the T-slot part of it. And the reason I have those in 2 setups is because once I take this material off on the top, then I want to go back in and get a new WCS and X and Y, just to make sure that I'm accurate and I don't get off on my contours when I do my final contours. Invariably, I always am off, a little bit, but I'll get as close as I can. So that's the 3rd setup. The 4th setup is the top of the part, where I do, drill and tap and my branding, my engraving. And then the last setup, I failed to put a vise on this. That's just to do a 2D chamfer. I'm not going to go through all of the work to throw in this simulated vise. But I like to use, this is the M-Lock 125. I like to use this vise when I do 3D, especially when I do 3D toolpaths, because the 3D toolpaths are aware of your fixture. So when I go into my setup, and you CNC gurus out there already know this, but I think this is cool. So right here, I don't know if you can see bottom of this menu where it says fixture, I've got my 4 bodies selected, and I worked with this vise to simplify it. And the vise basically, I've got my front jaw, my rear jaw, and my base, and then the screw. But yeah, so it recognizes that, so that when I run my 3D tool operations, it takes that into account. It avoids those surfaces. I can show you in this menu. Everything in yellow, it's not going to mill. That's the fixture. And then the green is what it wants to mill. So this first toolpath, that's a 3D adaptive. I'm going to rough away most of the material. I'm leaving a little bit, I think 1/2 mil on the wall and the floor, axial and radial. This is a 1/2 inch end mill, and I actually like to leave a little bit less with the 1/2 inch, like a 1/4 inch. The bigger it takes off later, the more chance it has to snipe, like in a contour, and kind of digs in and takes off more material than I want. That's my mill. I got a little slop in it, I think. I'm following that up with another 3D operation called flat. So it'll auto detect these flat areas. It's going to go in here and take off everything I've left on the floor. Then I'll do my contours. I'm doing my contours in the recommended step for my end mill. So yeah, it's going to go down there in 2 or 3, which is good, because then again, there's a little bit of tool deflection, and if I go down to multiple steps, I have more of a chance to pick that up. So those are my contours. And then this is the interesting one on this adaptive, and we'll go on. This is the dovetail. And I've never run this is a 60-degree dovetail tool. Never run one before on a CNC. I've done a dovetail a few times manually, and you've got a lot more, you got a lot more control when you do that. So I've got this ramp feed rate at the generic, just the standard that Fusion throws in, which I like because it's going to go in real slow when I can monitor it and watch it. Be a little voyeur. And then I'm running it at a very conservative RPM, but 1300 RPM. With a feed, let's see here, cutting feed rate, 173 millimeters a minute, feed per tooth, 0.1143 millimeters. I'll probably throw that up in inches when I get this done. But you'll see the trick here is I'm doing step overs of a quarter of a mil. Again, gonna do roughing passes quarter of a mil, and then my maximum step over is quarter of a mil. I thought about doing more aggressive, but I'm not in a hurry. So let's run this one toolpath so you can see this, and then we'll jump to the other. So there's the simulation of the bit. And again, I'm online here, so let's see how this does. Let me slow this down a little bit. It's going to go down slow, take just a little bit off, and then it'll go to the other side and take just a little bit off. And towards the end, you have more and more and more of the cutting edge that's in contact with the material. And so I think, I don't know. If you have an opinion on it, let me know. This is a coated high-speed steel bit. It's not an expensive bit. Perfect for manual milling, but why not throw it in the CNC? All right, beautiful. And it's worked for me twice now. So it worked. All right, so then I'm going to follow up with, your chamfer, and then let's move to the next setup. So the next setup, that's just to take the hat off. Here's op 3. Once the hat's off, I'm going to do my 3D adaptive, remove all the material, hit it with some contours, hit it with some chamfers. I have this chamfer set up for 0.5 mil, and this one I redid this one at 1 mil, 1 millimeter, just so it's a little more aggressive here. Let me turn off the model so you can see it. A nice aggressive so I can get my tool in and out. Right? And then my engraving, so you can see 250, 202, and I'm engraving that with a 90-degree V-bit. And I engrave all my stuff at 9600 RPM. I've got a 12,000 RPM spindle, so I'll engrave at 9600 RPM and about 500 millimeters per minute. Let me double check that. Yeah, 504 millimeters per minute, and it seems to do well. Bits last a long time. I do a lot of engraving on my Etsy shop. So that is op 3. Op 4, this is the second exciting part, I guess. Excuse my scroll wheel there. On this op, we're going to go in with a spot drill. This is a 120-degree spot. That way my drill bit coming in seats very nicely in that hole. They match up. I think my drill bits are grounded at 118. Maybe close enough to 120, right? So I'm going to go in there with a spot. I'm hitting it with a 17/64 drill bit. These, I have a whole bucket of 8mm grub screws, so I size these holes for 8mm grub screws. On a typical tool holder, they'll be bigger, but I'm doing that because I have the hardware. I did it in that because I'm following up with a bore. This is 1/4 inch end mill. I'm going to clean up the walls. Whenever I bore, I do not have through spindle coolant, so chips will end up at the bottom of the hole to be ground up, right? I'm going to do my chamfers for my tapping. I'm following up with a, let's see here, with a deeper chamfer. Yeah, this chamfer, this is my engraving tool bit. And so I did my original chamfer with, it's a flat bottomed helical chamfer 3/8, but it doesn't get into these corners right here. So if I follow up with this 90-degree chamfer bit, it'll get these corners, make them look really nice. Let's see. So you can see here, I wish that didn't reflect like that. You can see the corner is 90 degree, but when I follow it up, well, not 90 degree, but when I follow it up with that 90 degree engraving bit, I can get deep into that corner and it looks a lot better. Okay, I'm waxing along, I apologize. Okay, so then I'm going to run my tap. I've got a spiral flute tap, shoots, brings the chips up straight, so that's just a standard tapping operation for my 8mm. Then I'm going to tap with my 3/8 tap. This is a standard, gun tap, so this will do. I'll be doing this with tapping with chip breaking, so it'll go in the hole, go out the hole, and then I'll do my engraving. So this one says "Made in the USA," and then this one says "Power Forge, St. Jacob, Illinois." So I wonder if I can turn off this. Mouse makes things reflect too much. And then the last op is just final engraving, right? One and done. I had a guy comment on one of my videos. I don't know if it was a short or what it was, but he said I should have done the part that was in the video in one op. And I'm like, I don't know how I'm supposed to do that in one op, but evidently I don't know what I'm doing, because in one op I have to do everything, all the top features, right? Chamfer the holes underneath, and then not flip it and engrave on the front of it. I think it's so strange to see a dovetail end mill. First time using it, looks so strange. Alright, we need to check this dovetail to see if my tool post will fit that. That'll work. So G54 and Z is the bottom of this part. So I'm going to walk this in. I always get nervous when I switch up my G54 during different setups. So I'll walk this in, slow the feed rate down, and then let her rip. Stop right about there. Yep, stopped. I'm going to change it back to 100% feed rate. Coolant on. Do it. It's a mess, I'm sorry. I'm going to take the top off this part. Go back in and recenter an X and Y, and then finish up this setup. Okay, here's setup 2. Got the serial number and the tool slot. Just 2 more setups to go. Let's drill and tap. don't know if you can make that out. But I got the my maker's mark on there, made in the USA. It's upside down. I've got my center threads to adjust the center line of this tool holder, and then the 4 threads here for the grub screws. So I'm going to flip this for the last setup, simply to chamfer the bottom, and be done. Alright, so I think that worked out pretty well. What do you think? So I've got 2 tool holders milled. I think I'm going to blue these, but I'm out of bluing solution, so I need to fix them up before, and then I'll blue them. But I've got this stud. I've got some nuts to adjust the height, but I want a little thumb wheel. You know, they usually have a little thumb wheel, and then you can tighten the nut up against that to save your position. So I've got the mill on, and I'm going to drill and tap some 1-inch diameter round rod. And then I'll throw it in the lathe and knurl the sides of it so I have a little thumb wheel. And then I should be done. I'll put it all together. This next operation is just a regular tap, but I really like Fusion 360, where you can program tap with chip break. It's a little deep, so let's see how it does with the deepness. Uh-oh, it does not like that deep. Whoops. So what I did wrong was I have the drill. I drilled for an 8mm thread, and I'm trying to tap 3/8. So I'm gonna
I'll redo this, I'll throw the right drill in, and then retap this. Whoops. So I just pressed this green button and went up in Z, and it came right off. Now I'm going to back this tap up, inspect, whoops. Surprisingly, that did not break, but it did get pushed up into the collet, so I'm going to have to get a new tool offset, and we'll run this again. Let's try this again. In case you're wondering, I touched my tools off again, and I got a new Z height for the part. It was pushed down as well, 2 millimeters. See if this works. I like how the Siemens detected that. My Siemens controller, seemed to have detected the stop of motion and just cut everything off. Kind of a soft landing. So that's pretty cool, right? So let's see here. Let's run this again. Got my finger on the red button. See if we can save this part. Oh. Fingers crossed. Okay, that's what it should sound like. Roll focus. There we go. Pretty threads. Alright, let's pull this out and knurl the side, and I'll use a cutoff tool to cut my little thumb wheels. I've got to take my wife shopping though, so I will be back in a couple hours in different clothes to finish this job. Okay, I'm back. I'm gonna put the 3-jaw chuck on here. I don't need a 4-jaw for this. And this lathe, it's not a, it's not a quick change. You got a nice taper in here with a key, but it's not too bad. Not as fast as other lathes. There we go. And I've got it in low gear here to keep it from spinning. Right there. Okay. Whoops. So, get that part in there, get the knurling tool on here, and I'll finish this up. This isn't my favorite style of knurling tool, but this is what I've got. Get this going, put some oil on it. See if we can make some. I've got a medium pattern that I'm going to do. This see how it looks. And the trick is to not crash this thing. Okay. See how that looks. That'll work. Let me clean it off and I'll show it to you. Nice little bit of texture there. Oh. Little texture. So let's cut this off. How big are these things? About 1/4 of an inch. And this doesn't have to be precise. But I'll just go about 5 millimeters. Well, yeah, that'll work. Okay, before I go all the way through, I'm going to do a little back chamfer. That'll work. Now, whoops. Try to find the same spot. Cut this off the rest of the way. Oh, that's a little warm. I got a little bit of a ragged edge after I cut it off, so I'm going to take the old hand chamfer and try to deburr this a little bit. Let's finish this with a file. And use the drawing method. And that looks pretty good. Okay, what do you think? Hope that's focused. Now I can go put it all together. Alright, so I'm going to blue this. I'm going to blue this as well. This goes down like this, like so. There we go. Okay. Might have to chase this. Nope, there we go. And then the other nut goes on top, like so. I'll probably try and find a nut that doesn't have this flange. I mean, this works, but. And then in the lathe. What do you think? So that was a fun project. I actually did draw up a file to make my own nuts. I didn't run it because nuts are cheap. But this thumb wheel is pretty cool. I think to get a replacement for McMaster Carr for the stud and the thumb wheel and the nut, it's like $16 to $18. But, you know, I basically ran that for free. But yeah, I like it. Anyway, guys, I hope you enjoyed the project. It was pretty fun. I'm probably going to make a couple more of these now. It's kind of neat to be self-sufficient and to make your own stuff. That's why I got the Sile, to fart around in my shop and to make stuff and to think and to solve problems. So if you stuck around this far, thank you. Thanks for watching. Have a good one. Take care. Bye.